quick basic notes. Exercise 2E. So we've done so far triangles, quadrilaterals. Then we're now moving on to, well, what if you didn't have just triangles or quadrilateral? What if you had a pentagon, hexagon, heptagon? How do we solve the angles within it? So it starts off with, what is a polygon? Polygons are shaped with end straight sides. What I call n just means we don't know what the number is. So it could be 5 straight sides, 10 straight sides, could be 100 straight sides. When they say regular, and maybe highlight, underline, or star this, regular polygons means specifically that not only do they have straight sides, but all the sides are equal in length and equal in interior angles. Just to highlight what I mean by that, so polygon is any sided shape, right? So you can think of any number sided shape, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are all called polygons as a general term. Let's take a 5-sided shape. What's a 5-sided shape called again? Pentagon. Very good. Now, pentagon, 5-sided shape, doesn't always have to look like this. That's your typical pentagon that you would have seen in primary school, but it's a 5 sides, right? So we've got 1, 2, 3, 4, 5. That's called a pentagon. But I could have drawn the shape like this. 1, 2, 3, 4, 5. That's still 5 sides. So this is 1, 2, 3, 4, 5. Technically, this is a pentagon as well. The difference between the two, the one that you often see in primary school, is technically a regular polygon. And a regular polygon means that it has to have all sides are equal in length and all the angles are equal. Okay, so if it was angle, let's call it A, all the angles are A. Okay, that's called a regular polygon. Okay, so when they say regular hexagon, you should be thinking of the typical one, the one that looks like on your soccer ball. Okay, that's a regular hexagon. But if they don't say regular, then you can draw any 5 or 6 or 7-sided shape you come up with. So for example, a 10-sided shape, if I had to draw a regular one, I'd just struggle. I don't even know how to do the little increments to make 5 on the top, 5 on the bottom. But if I just asked you to draw any 10-sided polygon, do you know what's the easiest shape? Can anyone think of it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Technically, a star is a 10-sided shape, but it's not regular. Okay? Yeah. Yeah.
I wrote print some in the library.
Sure, but not now.
I'm printing a copy of this.
Yeah, you can do that later. Right now I'm writing notes. All right, so that's the difference between polygon, just a normal polygon, and then a regular polygon. Okay, so when they say regular, make sure all sides are the same, all angles are the same. Now this table here is just to help you remember the names. You got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's all you really need to remember. If there's anything beyond that, Google it. Okay, this is the main ones that we use. We don't actually use much more than that. Okay? Now, let's recap. The total angles in a triangle must add up to what again? 180. And then the total angles in a quadrilateral must add up to 360. Today's lesson, you're going to be able to tell me the answer for all these other ones. Even if I gave you a 99-sided shape, you should be able to tell me the angle. Right? So let's look at a pattern. So if we scroll down a bit, let's look at a pattern that you can see. Here's a triangle. How many sides does a triangle have? Elliot? How many sides does a triangle have? 3. Very good. And in 3, we said the 3 angles must add up to 180. So we see that there's only one triangle, and if you have 3 angles there in a triangle, we know it equals to 180 degrees. What's interesting is that if you can find triangles within any of the polygons, you know it's always 180. Now, if you have a look at a 4-sided shape, see a 4-sided shape, you can always cut it into two triangles. Now we already know three angles here, those three should add up to 180. But then if I added with these three angles, that should also add up to 180. What's interesting is that, well, if that's 180 here, and notice these two corners make up the one angle, then together it has to be 360. Right? That's where the logic comes from. So, when we start to see a pattern, I want you to note a pattern here. It took the other class quite a while to come up with this pattern, by the way. So, I want you to see this. Three sides has one triangle. Because clearly there's only one triangle there. When you have four sides, there's clearly two triangles there. If you have a pentagon, five sides, we can cut corner to corner, that's one triangle there, and another corner to another corner, that's 1, 2, 3 triangles. So here, fill it in. We're starting to see a pattern. 3 gives you 1. 4 gives you 2. 5 gives you 3. How many triangles do you think 6 would give you? 4. So the next one's 4. What's the pattern? What's the pattern? So if I know the number of sides, I should be able to figure out the number of triangles because there's a pattern here. What's the pattern? There's 2 less. The other class was only seeing it as add 1. But then if I said, well, what's 99 sides then? They're like, you're not going to add 1 until you get to 99. There has to be a quicker way. The pattern was that you always minus 2. So this one should be 5. So if you have a 99-sided shape, how many triangles do you expect? 97. That's it, minus 2. So why do we want to know the number of triangles? Because we know the angles in a triangle add up to 180. So if you have 3 triangles for a pentagon, then you end up actually doing 3 times 180. Now we know that 2 times 180 was 360 for quadrilateral. Pentagon, oh sorry, Sully? Oh, no. Well, until we get to the end. But that's good. Good that you know the formula. 3 times 180. What's 3 times 180? 540. Now, for those who weren't sure, all you have to do is add on an extra 180. Because you already know one group is 180, 2 groups is 360. Well, then 3 groups just add another 180. So that gives you 540. If you want to know the next one, just add another 180.
So it goes up 180 every time.
Yes. So, in this case, this will be 4 times 180, which you can use a calculator. Anyone know? What's 540 plus 180? 720. Very good. And then if I did a heptagon, all the angles must add up to 5 times 180, which gives you 900. Very good. So there's a pattern here, and now this is where Sully can come in. The pattern was, if you know the number of sides, take away 2 will tell you number of triangles. And when you have the number of triangles, you times by 180, you should get the total angle that it adds up to. So what's the formula, can I please have Sully down there?
If you call the number of sides like n, like it says in the sheet, if
Yeah.
you say n, it's n minus 2 because that's minus 2 every time for the so for the number of triangles in it. So it's just n minus 2 times by 180 equals the answer.
Beautiful. So just like what we said before, if you want, the S means sum. So total sum of the angle. So total sum of the angle. So I'm going to write here sum of interior angle. That is equal to n minus 2, which just tells you the number of triangles. That's what it tells you. So number of sides that you have, whatever shape you got. Take away 2 tells you number of triangles. Elliot, please don't speak while I'm speaking. Number of triangles times 180, because we know that each triangle has 180 degrees. That should give you the total sum interior angle. Okay, so no matter what shape you get, even if it's a 99-sided shape, 97 times 180, whatever that is, all those corners of a 99-sided shape, if you add it all together, it should add up to the total angle. Okay? So, flip over to the next page. That was the pattern. I just wanted you to see where the rule comes from, rather than just memorizing the rule, because that means you can always figure out the rule yourself. Let's do this example. Example 1. An octagon clearly has 8 sides. So then how many triangles do you expect? Can I please have Josh? 6. Very good, because you just minus 2. So it should be 6 minus 2. That's according to the rule. And minus 2. So it should be 6 minus 2. And the rule was, if you know there's 6 triangles, to find out the angle sum, each triangle has 180. So you times it by 180. Now what's 6 times Oh, sorry, that should be 8 there. What is 6 times 180 equal to? We got up to 5 before. 1080. Write that down. So we know that when they ask what is the sum of a regular octagon, the angle sum, they're really asking if you added all the angles together inside an octagon, what it should add up to? It should add up to 1080. Okay? Let's do the next problem. Example 2. Let's copy this down. Example 2 now. You got a hexagon. Now that's not your typical hexagon. It's not a regular one. This one has 1, 2, 3, 4, 5, 6 sides. If it has 6 sides, we need to know, well, if we add all the angles together, what should it equal to? Now on your previous page, we already did it. Hexagons, what should they all add up to?
720.
720. So remember, it was 6, take away 2, times 180, and you guys already did it already. It was 720 degrees. So that means we just need to add all these 6 angles together. You've got this square box plus a square box plus 150 plus 120 plus 130 plus this random degree, A. So let's write it down. We've got A plus 130 plus 120 plus 150 plus, now what's the boxes again? 90, because that's the right angle. So 90, I've got one here and I've got another one over there. So times it by 2. You could do 180. Very good. Now, anyone got quick maths? What's all that add up to?
720 minus 580 is 8.
Is that 580, is it?
Yeah.
Let me check. 130 plus 120 is 250. 250 plus 150 is 400. And that's 180. Yes, that's correct. So it does all add up to 580 there. So something plus 580 equals 720. 140 is the correct answer. So A must equal to 720 take away 580, which is 140. So this angle right here must be 140 degrees. Okay? So the logic is we just need to know what's the total sum. Once you know the total sum, you can figure out individual angles. Here's your last example for today. And remember, you can work on either 2C or 2D. The reason why I put in the last example is because when I put on a test, students don't know what I'm asking for this bit here. They often ask that question. So I want you to put a note. Boys, put a note here. The third example, when you're doing the third example, when I ask for an interior angle, don't be disrespectful. An interior angle, remember, interior means inside the shape. And means 1. So they just want to know one of the corners. Now you see, they say regular. And remember, what's the definition of regular again?
All the angles are equal.
All angles are equal and all sides are equal. So here, a nonagon, how many sides does a nonagon have? 9. Okay, I just don't know how to draw a 9-sided shape. So if I'm going to make it up, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9. Not a really good shape. I can't draw a 9-sided shape. But the idea is that all sides are meant to be the same. Now here's the question. I want to know one of the angles. So just that. Now remember, all the angles are meant to equal. So that's A, that's A. All these corners are meant to add up to a certain number. There should be 9 angles in total. So what is, if it's a 9-sided shape, so n minus 2 times 180, which is 7 times 180. Yes, that's right. 1,260 is correct. And that's very good. Because it's equal angles, and you've got 9 of them added together, a way of thinking about it is you're saying A plus A plus A plus A plus A. How many is that? That's 5. 6, 7, 8, 9 has to equal to 1,260. But this is like saying 9 groups of A. So that's why it's easier to figure out. Instead of doing 9 times what gives you 1,260, you can work out A as 1,260 divided by 9. Now, I don't have my calculator. Let's see if we can do that by hand. Unless someone has a calculator, How many 9 goes into 1? 0. Carry the 1. How many 9's in 12?
It's 140.
Is it 140? Yes, you're right. It is 140.
Yay.
Very good. So each one must be 140. That's what interior angle means. Each one has to be equivalent to.
It's S over N.
Yes, that's correct too. Which I haven't taught you guys that. But there you go. That's your last example. Those are the ones I'd normally put on the test. But I did put one, an interior angle. So put a note somewhere to know what an interior angle means. And that's it. That's exercise 2E, polygons. You have 2C, 2D. That's due by the end of this week. And then end of next week is 2E. So
This one, I remember.
that's what you'll be working on. Let me stop the video.